So yesterday we talked about if a rhombus has this, then it's a parallelogram. If, all the different things that go along with it. Today it's really just the converses of that. So like theorem 616, for instance, again, don't worry about the numbers, says if the diagonals of a parallelogram are perpendicular. So we said it's a rhombus. If it's a rhombus, then the diagonals are perpendicular. Today we're saying if the diagonals are perpendicular, then we know it's a rhombus. So all you need to know is that the diagonals are perpendicular. Sorry, I can't speak today. And it will be a rhombus. Okay, so that's the first one. If the diagonals are perpendicular, it's going to be a rhombus. The second one says if this is just one. Sorry, I apparently did not read this before I. So this should be if one diagonal of a parallelogram bisects a pair of opposite angles, then the parallelogram is a rhombus. So yesterday we said it will bisect both, but technically to know that something is, that's not a rhombus. To know that something is a rhombus, you only technically need to know that one of them bisects. If one of them does, the other one will also, okay? So if we know this, we know it's a rhombus, okay? You don't have to know both of them are bisecting. You just have to know that one. And then the third one, the converse of our third one yesterday, if the diagonals are congruent, then what's the parallelogram going to be? If your diagonals are congruent, that's a rectangle, right? That one's the rectangle. So this one will be rectangle. Okay. Okay, so here's what you're going to get today. You're going to get a picture. There's going to be markings. You're going to have to decide, is that a rhombus, a rectangle, or a square, and how do we know? What's the reasoning behind it? So if you look at this first picture, it says, can you conclude this parallelogram is a rhombus, rectangle, or square? So we know it's a parallelogram, okay? We want to know rhombus, rectangle, or square. So if you look at this first picture, based on the three theorems that we just talked about, what would this one have to be? This is a rhombus. The reason for it? One diagonal bisects opposite angles. Okay, so we know it's a rhombus because those opposite angles are getting bisected. Okay, so look at the next one. Thinking about what we know here, rhombus, rectangle, or square? Look at those markings. So break it down. You have a 90-degree angle in the middle. What's that mean? That means it's a rhombus. Okay, so we know because of this that it's a rhombus. What does all this tell us? The red markings. That it's a rectangle, right? That means our diagonals are congruent. So because of the red, we know it's a rectangle. So if something is a rhombus and a rectangle, it's a square, okay? So this one is a square because diagonals are congruent. Okay, that's making it a rectangle. And diagonals are perpendicular, making it a rhombus. Okay. Questions on that? All right, third one here. So you have 4 segments that all have a length of 7. Rhombus, rectangle, or square. Rectangle. Why is it a rectangle? Right. So we would say this one's a rectangle because the diagonals are congruent. Okay. Last one there. Rhombus, rectangle, or square? That's a rhombus. Why is it a rhombus? Right. Diagonals are perpendicular. Okay. And like I said, when all we're working with are rhombuses, rectangles, and squares, I feel like that information is fairly simple, right? You see perpendicular or bisected angles, you think rhombus. You see congruent diagonals, you think rectangle. On the block, we're going to throw in new figures, and there's going to be new requirements for those figures. So you really need to make sure that you know this stuff really well. Like, I know that the diagonals being perpendicular makes it a rhombus. I know that the diagonals being congruent makes it a rectangle. So that when you see those markings on a quiz, because it's not going to say, here's a rhombus, sometimes it will. Other times, it's just the markings that tell you. So if it is all based on markings, you need to know those markings, okay? Okay, second example. You have 2 pictures here, and it says, in order for the parallelogram ABCD to be a square, what would the value of x have to be, okay? So forget the markings for now. Just considering that we know this, we know that 6x plus 6 is that angle. What would x have to be if this is going to be a square? Okay, so we're trying to make this one, oops, a square. I don't know why that text thing came. Hold on. How do you know? Like, what would you do? Right, so if it's going to be a square, we have enough information to know that the opposite sides would be congruent, right? What we need to know is that the diagonals are perpendicular. So we would have to say 6x plus 6 equals 90, and then solve for x. So take away the 6x equals 84, and then divide by 6, and 84 divided by 6 is 14. So if x is 14, then that figure will be a square. Okay, diagonals would have to be perpendicular. Okay, so now look at the second one. It says, in order for EFGH to be a rectangle, okay, so for this guy to be a rectangle, what would y have to be? What would you do with that? Set them equal, right? We know that the diagonals are equal. Okay, and here's the thing. People are always like, wait, that's not the whole diagonal, so why would you set those equal? But we know in a rectangle, diagonals are equal. We know in a parallelogram, diagonals do what? Bisect each other, right? So if that's the case, this will always be that all 4 of those are equal in a rectangle. Not in a parallelogram, but in a rectangle, this will always be true. So you can say that 5y plus 3 should equal 7y minus 5, and then just solve for y. So take away your 5y and add your 5. You get 2y equals 8, divide by 2, so y would be 4. Okay, so in order for that to be a rectangle, y would have to be 4. Questions on that? God bless you. Okay, this last one, a question to ponder, and I'm actually going to have a few of you try it. If you have 4 people and 2 ropes, how could you make a rectangle and make sure that it's a rectangle? Okay, and we're gonna lay this out, so I'm not